In this video, we're going to explore one of the most advanced and accurate components used in HVAC systems, the electronic expansion valve, also known as the EEV. So, what exactly is an electronic expansion valve? An EEV is a metering device designed to regulate the amount of refrigerant entering the evaporator. Unlike the thermostatic expansion valve, which functions mechanically, the EEV works electronically by receiving input from sensors and control signals sent by the system's controller. Its purpose remains the same: to drop the refrigerant's pressure and control superheat at the evaporator outlet, but it does this with far greater accuracy and quicker response time. Let's now understand the main parts of an EEV. Stepper motor. This is the core element of the valve. It moves in precise increments to regulate the refrigerant flow accurately. Valve needle and seat. These two parts manage the valve's opening and closing, controlling how refrigerant passes through. Controller acts as the system's brain, sending control signals to the stepper motor. Sensors. These detect temperature and pressure at the evaporator's inlet and outlet. Now let's see how an electronic expansion valve works. The controller collects pressure and temperature readings from the sensors. It then calculates the superheat, which is the difference between the suction line temperature and the evaporating temperature. Based on this value, the controller sends an electrical command to the stepper motor. The motor turns a specific number of steps, moving the needle in or out, which adjusts the valve's opening and controls how much refrigerant enters the evaporator. When the superheat value is too low, the valve slightly closes to reduce flow. When it's too high, the valve opens wider to allow more refrigerant in. This process ensures maximum evaporator efficiency and prevents liquid refrigerant from flowing back to the compressor. Advantages of EEV: extremely precise refrigerant control, quick reaction to load variations, better overall energy efficiency, improved compressor protection, ideal for inverter-driven and variable speed systems like chillers and VRF units. For instance, imagine that during the night, as the temperature drops, your system's cooling demand suddenly decreases. A TXV takes time to adjust to this change, but an EEV instantly receives live data from its sensors and corrects the refrigerant flow within seconds, avoiding both overfeeding and starving conditions. Applications: inverter split AC units, VRV/VRF systems, chillers, heat pumps, and any refrigeration system requiring precise flow regulation. So, that's how the electronic expansion valve functions, a compact device with a major impact on improving energy efficiency in HVAC systems. Thanks for watching. Don't forget to like, share this video, and subscribe to our YouTube channel, Intact Knowledge.